Hey everyone, this is Miss Valentine, and you are watching the 17.2 Notes presentation on nuclear energy. Nuclear energy really came to its peak in the 1950s and 60s. It was seen as the power source of the future because the fuel is clean and plentiful. But we finally figured out that the waste was damaging, and there's also a threat of nuclear meltdown as well. So a lot of plans were canceled in the 70s and 80s, and a lot of the construction was abandoned. So today, nuclear power still accounts for a reasonable chunk of our energy, 17% of the world's electricity, and it is seen as a possible bridge off of fossil fuels. So we still see it being supported in some places. It really just depends on the geology of the area and then what they have available in terms of uranium fuel, which we'll talk about in a few slides. So, nuclear energy is energy released by fission or fusion reaction. It represents the binding energy of an atomic nucleus. So, basically, when you collide two atoms together, the energy that comes out of those atoms' nuclei is released as fission energy, and it's a ton of energy. So the forces that hold together the nucleus of an atom are 1 million times stronger than the chemical bonds between atoms. So, like hydrogen and oxygen are held together by hydrogen bonds. Take that bond times a million, and if you split that bond, think about how much energy that produces. So, in nuclear power plants, they are splitting atoms of uranium, and the bonds that are holding that heavy element together um, release a ton of energy that we can then use to boil water, to make steam, to turn a turbine, just like we talked about before with other types of energy. So the nuclei of the uranium atoms are bombarded with atomic particles called neutrons, and they collide with the nuclei and split it in a process called nuclear fission. So if you think of a fissure, it's like a crack. So fission is like splitting something apart. The opposite of fission would be fusion, and that's when you are bringing two atoms together and their nuclei together, which really only happens at super duper duper hot temperatures. The sun is an example of where you see nuclear fusion. But nuclear fission, or splitting those atoms, is what we use in nuclear energy. So, nuclear fission releases a tremendous amount of energy and then more neutrons, and those neutrons combine or collide with other uranium atoms, and that's where you get this reaction that creates an enormous amount of energy. Here's a picture just showing you bombard a U-235, uranium-235 nucleus with a neutron. It splits it up and it creates these smaller daughter nuclei and a ton of energy. It also releases more neutrons, which collides with other nuclei. So it's like a chain reaction. All right, here we are at our pit stop. Which atomic particle collides with uranium to cause the atom to split? And then what is this process called? Pause the video while you answer those questions. So, how does nuclear energy work? Well, it's actually very similar to how we saw coal, oil, natural gas, and other heated uh, types of power work. So, the chemical reaction from the nuclear fission is used to heat water, and that produces steam, which turns a turbine, and that turbine creates electricity through a generator. So, again, it's pretty much the same exact process as you see in a coal power plant or a natural gas power plant. It's just the source of heat for heating the water is nuclear fission instead of burning coal, oil, or natural gas. So here's a picture of a nuclear plant. So these fuel rods and control rods are part of the heating unit when the fission actually takes place. And it creates a lot of steam. That steam in turns a turbine. The electric generator creates the electricity, and then that goes out to us. Now, because there is so much heat, so much energy from a nuclear power plant, they actually have cooling towers. So that's what those big structures are that you see at a nuclear power plant. What's coming out of them is just steam. There's just so much energy that they have to keep them cool. And so when you hear the word nuclear meltdown, it's usually referring to it overheating, the fuel rods overheating. And that's when you have things that fall apart in nuclear accidents. So, a good thing about nuclear energy is that it's very concentrated as an energy source. You need a tiny, tiny little amount compared to the number of train cars of coal that you would need to produce that same amount of energy. Nuclear power plants also don't produce air polluting gases. Again, what you see coming out of the large structures at nuclear plants is just steam. They also have less radioactivity than coal fired power plants, which is kind of crazy because you think of nuclear as being more radioactive, but coal actually has radioactivity as well. And because it's so dirty as a fuel, it also has radioactivity. And then countries that don't have a lot of fossil fuel resources, they don't have coal, oil, or natural gas, they rely on nuclear plants to supply electricity because you only need a small, small amount of the fuel in order to use that type of electricity. Now, some places have built nuclear energy in places that are not very smart to have them. I think we'll talk about nuclear accidents in a few slides here, but for example, Japan does not have a lot of access to fossil fuels, but they built their nuclear plant and it ended up having a meltdown when they were hit with an earthquake. So you need to build nuclear power plants in places that don't have earthquakes or don't have a lot of geologic activity. So, why aren't we using more nuclear energy? The main reason is that building and maintaining safe reactors is very, very expensive. And it makes nuclear plants no longer competitive with a lot of the other energy sources that we have. We recently in Ohio had a nuclear bailout bill. It was like, had all sorts of scandal with it. There was a bribery scheme and yada, yada, yada. But anyway, the idea was that we customers were supposed to pay extra on our electric bill to keep our nuclear plants alive here in Ohio. And that since has been taken back once they found out that there was a whole bribery scheme going on with that. They're going to try to make sure that us consumers aren't paying for our nuclear power plants to continue operating. In truth, they are just so expensive that it's not worth it to keep them going. Make sure I don't miss anything. Okay. Here we are at another pit stop. What are some of the advantages of using nuclear energy? And then what is the main reason we don't use more nuclear energy? Pause the video while you answer the question. So, one of the bigger challenges associated with nuclear energy is that we don't know what to do with the waste. It is very, very radioactive and very dangerous, and nobody wants that in their backyard. So, finding a safe place to store it has been a major challenge. We did try to store it in a place called Yucca Mountain, and that actually fell through. We no longer do that. So, right now, we store it at the nuclear facilities. So, the picture on the very first slide showed a cooling area where those fuel rods are being stored now until we figure out what we're going to do with them. And unfortunately, the products that come after nuclear fission are really radioactive and they last for tens of thousands of years, hundreds of thousands of years, even. So we are creating all of this waste that we don't necessarily want to deal with, even though it's going to be a problem for a very, very long time. So I mentioned the earthquakes in an earlier slide, but storage sites for nuclear waste also needs to be in a place that is geologically stable. So basically no earthquakes in that area. And that is supposed to prevent any big nuclear accidents from happening with the waste. Scientists are researching a process called transmutation, and that would change the radioactive elements in that nuclear fuel into something that is a little less harmful. However, it's really challenging. It's hard to manage that radioactive waste. So there's progress being made, but really we're more focused on trying to find a place that we can store this nuclear fuel or the waste product. So there are safety concerns with nuclear energy as well. In a poorly designed plant, the fission process can get out of control. Again, there's a ton of heat that's being produced, and so that's when you get these nuclear meltdowns. Chernobyl is the most familiar example of a nuclear meltdown, and that was in 1986. And it was an unauthorized test that caused explosions and made radioactive materials go out into the air. So basically, nobody could live around that area anymore. Hundreds of people in Ukraine died from radioactive exposure to the explosion, and then even today, you find parts of Northern Europe and Ukraine that are still contaminated from that disaster, even though it was well over 30 years ago. So radioactivity, again, it can last for a very long time, and so the entire area of Chernobyl it's actually recovering as an ecosystem because there's no humans there anymore, but there's still radioactive elements in the soil. The most serious nuclear accident here in the United States was in 1979, and that was at Three Mile Island Nuclear Power Plant in Pennsylvania. And fortunately, it wasn't as big as Chernobyl. However, it did kind of scare us into making a lot more safety improvements at our nuclear plants. So nowadays, there is a lot more safety measures in place to ensure that such an accident does not happen again. The most recent disaster that we are aware of is in 2011, the Fukushima Daiichi accident. And that was when there was a tsunami and earthquake off the coast of Japan. The tsunami disabled the emergency generators, so that would have provided power to control and operate the pumps necessary to cool the reactors. So basically, you didn't have the water cooling systems in place to cool down the fuel rods. So then you had a nuclear meltdown, or actually three nuclear meltdowns. Then there were some explosions, and then a release of radioactive materials. So in Japan, the Fukushima disaster was kind of a wake up call to them that, hey, maybe we should find some other way to produce energy other than nuclear. Now, they don't have a lot of access to fossil fuels, which is the primary reason they had nuclear, but it's become pretty clear that they probably need to be looking more at alternative fuel sources like solar, wind, and other things aside from nuclear power, because the entire country of Japan is along a fault line. All right, so here's a pit stop. You probably have a few different possible answers for this one. What are some of the disadvantages of using nuclear energy? Pause the video while you answer the question. So, what is the future of nuclear power? It's kind of actually still up in the air. Nuclear fusion is a technology that we have been exploring to try and combine atoms from small atoms to larger atoms, and fusion releases even more energy. We have developed the technology for atom bombs, which is not a good use of it, but it could actually be a safer energy source than nuclear fission because you don't have as much radioactive byproducts. Now, the reactions themselves are a little bit more dangerous. So, nuclear fission is something that we have not managed to like maintain on an ongoing basis. We can use it in an atom bomb, instantaneously cause fusion. Fusion is continuous in the sun, the combination of hydrogen atoms into helium. That's how we get our energy from the sun. But that radioactivity is actually a little less harmful than the radioactive products of uranium 235. So even though nuclear fusion is a good possibility, it's still technically too difficult to achieve at this point. You can see the temperatures on the screen there that are required over 100 million degrees Celsius or 180 million degrees Fahrenheit. And just think about what you need to create that sort of temperature, how much energy would need to be put in to raise the temperature that much. So we may never use it as an energy source. We may only see it here on Earth in damaging ways through nuclear weapons, which hopefully we won't actually see any nuclear weapons go off, any nuclear fusion on the Earth go off in the future. All right, and here we are at our summary page. Check out this damn nuclear plant. And that is actually a damn, wait, did I say that right? A dam. Look at this damn nuclear plant. Um, that is actually a dam right here next to a nuclear plant. I was amazed that I was able to find that picture. All right, you guys should read through your notes again, and you're writing a 5 sentence summary about the main points related to nuclear energy.